This video will cover verification of trigonometric identities from your book in section 5.2. When you verify trig identities, there are some things that you need to remember. Only work on one side of the given identity. Remember that you are not solving the identity. You're simply transforming one side of the identity into the other side. The first step in verifying trigonometric identities requires you to convert all cosecant, secant, tangent, and cotangent functions into their basic sine and cosine functions. This means you need to remember your quotient and reciprocal identities. You may need to use your Pythagorean identities as necessary to convert between functions. Remember that this means that your functions need to be squared. You may also need to use your even and odd properties in order to remove a negative sign from inside the argument. Let's begin by verifying the identity shown by manipulating the left side of the identity into the right side. Remember that we always want to start with the most complicated side. So our identity is sine theta times tangent theta plus cosine theta is equal to secant theta. We're going to begin by manipulating that left-hand side, so I will write LHS, and I'm going to go ahead and write it again. Notice that we have a tangent theta right here. So we want to convert that into sine and cosine. When we do this, we end up with sine theta times sine theta over cosine theta plus cosine theta. Now we're going to carry out that multiplication that you can see here. So in doing that, we have sine squared theta over cosine theta plus cosine theta. In order to add these two terms, we need to have a common denominator. That common denominator will be cosine theta. So I am going to multiply the second term by 1 using cosine theta over cosine theta. When I carry out that multiplication, I get sine squared theta plus cosine squared theta. My common denominator is cosine theta. Using that Pythagorean identity, we see that this results in 1 divided by cosine theta, which is secant theta, which leads us to the right-hand side. This is how you verify this identity. Remember, we manipulated the most complicated side, and we put everything in terms of sine and cosine before we started. The next identity we're going to verify also has a more complicated left-hand side. So we will start with that, transforming it into the right-hand side. So again, we start with the left-hand side, which is cosine x minus cosine x times sine squared x. Now, there's two ways you can approach this. So I'm going to begin with what I will label as option 1. And I'm going to do this by factoring out a cosine x from both parts of the expression. When I do this, I get cosine x times 1 minus sine squared x. Now, if you remember from the Pythagorean identities, and I'm going to label this again as an aside because it's not part of your problem solving, our Pythagorean identity in the traditional sense is sine squared x plus cosine squared x equals 1. Now notice that if I subtract sine x from both sides, I get that cosine squared x is equal to 1 minus sine squared x. And that is exactly what I have here. So I can come back to my problem and make this substitution. Cosine x times cosine squared x will give me cosine cubed x, which is my right-hand side, and I am done. Now, if you saw a different way of approaching this, and you said, I just don't know what to do, maybe I could start by multiplying, making that substitution for sine squared x, and then multiplying through. Let's see where that gets us. So I'm going to label this as option 2. Again, it's just as correct. There are many ways to verify identities. I'm going to start with the left-hand side. Cosine x minus cosine x times sine squared x. But now what I'm going to do is make a substitution for this guy. So that's going to look like cosine x minus cosine x times 1 minus cosine squared x. Now, the careful part here is when you distribute this, this has to go with it. So when I make this distribution, I get cosine x minus cosine x minus negative cosine cubed x. You can see, I hope, that these two cancel, and then negative times negative would give us positive cosine cubed x, which is, again, our right-hand side.